Ankit Ranjan. I'm from NIT Patna doing my master's here. I have 2 years of teaching experience in different engineering colleges. Today I am here to discuss the topic viscosity. What is viscosity? Before going there, we should first know how many types of there are fluid. There are two types of fluid we generally take in. That is real fluid and ideal fluid. In ideal fluid, everything means viscous or resistance property is zero. We are taking it, neglecting it. But in real fluid, when we comes to real fluid, it follows a single condition. It follows a condition that is a no slip at boundary condition. No slip boundary condition means the layer which is just in contact with the boundary of any another layer or any another particles or any another surface remains in same motion. Means if the boundary is in the rest, the layer which is in contact with that boundary is also in the rest, and the layer is in the motion if the boundary is also in motion. So like if there is a boundary or a surface and a flow is occurring over that surface, then the layer, so what I am talking is here a layer. So we consider that the flow of the river, the flow of any fluid is flowing. That flow is in a layers, in the form of layer. Like this is the segment of a fluid. Then this fluid contains too many of layers, like this. So this is suppose of a thickness of T. Then this thickness of T is differentiated between too many small thickness of layer. So that layer I am talking about. So the layer which is in contact with that boundary is also remain in rest, and we assume, and this is the condition of a real fluid, that it follows this no slip condition. So we can say the velocity at that point is V0, means U is equal to 0 here. As we going upward in the flow, then we can see the velocity is increasing, and at the top of the flow, the velocity value attains its 90% of the velocity. This in class 12th, up to class 12th, we studied that the velocity of the upper layer, our topmost layer is we taken V, means it attains the full velocity. But in higher education, in masters and in higher education, we assume that it attains only the 90% or 0.9 of V. So just leave that portion because it is not in your class 12. So we assume that it attains the velocity V. So this creates a velocity gradient. This creates a velocity gradient, and this creates this is also showing that the different layers having different velocity. Different layers having different velocity, so relatively their motion will be different. So upper layer moves faster than the lower layer, and if any body or if any layer is moving above the another layer and its motion is high and its velocity speed is high, then it creates a frictional force opposite to lower layer. Means there is, if the upper layer is moving with another velocity and lower layer is moving with another velocity, then there is a relative motion between them, and there is a concept comes of a frictional force, and where the frictional force comes, there is a viscosity comes in the motion, in the picture. What is viscosity? So first of all, we should know what is the frictional force is directly proportional to the rate of change of velocity with respect to distance or the depth, and frictional force is also directly proportional to the area, the contact area between the two layers. So when we simplify, equate that, we can write force is directly proportional to area and velocity gradient. And when we remove the proportionality sign, there comes a constant coefficient, that is frictional coefficient. And this is called coefficient of viscosity. Means a person can say viscosity comes under the action when the relative motion is different, when the two layers having different velocities, when the two layers having different motion, means no slip condition. Simply we can say no slip condition is creating that difference and creating a frictional force here. So this coefficient of viscosity is sometimes saying dynamic viscosity and sometimes it is saying kinematic viscosity. There is a difference. A difference is that when we talk about the dynamic viscosity, it is just when we applying a force over a layer and we are pulling it, then the frictional force, then the viscosity comes in the under the action is dynamic viscosity, and kinematic viscosity comes when the gravity action also includes in that. So means dynamic viscosity, simply we can say kinematic viscosity is equal to dynamic viscosity upon density of the fluid. It also depends upon the density of fluid. Means more the density of the fluid, more is the kinematic density. And our dynamic viscosity doesn't depends upon the density of the fluid. And also this dynamic viscosity depends upon the temperature. As we increase the temperature, that dynamic viscosity decreases. And also so from formula we know that frictional force is equal to coefficient of friction into A into velocity gradient. The unit of coefficient of viscosity is Newton second per meter square or Pascal second, decapoise, or in dimension we can write here ml power minus 1 t to power minus 1. So here we are seeing a question, we are seeing a application of that viscous force. So here in the question we have given, this is the question of IT mains. So the question is that the thickness of a glycerine is, we know that glycerine is another form of semi-liquid, so fluid. The thickness of glycerine is 3 mm, or by converting in meter it is 3 into 10 power minus 3 meter. Coefficient of viscosity, that viscosity is 2 Newton second per meter square. Change in speed is 6 into 10 to the power minus 2 meter per second. And area of plate is 48 into 10 to the power minus 4 meter square. Means the question is saying that a plate is over a glycerine layer, and the find out the force required to pull out that plate over the glycerine. Means if we are giving a velocity to the plate, we are giving a speed to the plate is 6 into 10 to the power minus 2 meter per second. Then what is the force applied over the plate to just pull out that plate over the glycerine layer? So this is the same. This is the question of from the same concept. Means you have to find out the F value, and you have all the values are given here. Means F is equal to, we know that coefficient of viscosity into area into velocity gradient. Just to put out the values over here, means 2 Newton second per meter square into area. Area of plate is given 48 into 10 to power minus 4 meter square into change in speed, means du. Here du is not given, so up the top layer having a velocity given here 6 into 10 to power minus 2 meter per second, and as we know the bottom layer velocity is 0, so we can evaluate the value 6 meter. We can write the value 6 into 10 to the power minus 2 meter per second, and change in depth is thickness of the glycerin, that is 3 into 10 to power minus 3 meter. So after calculating, we can find the value is 192 into 10 to the power minus 3 Newton. So that much of force we have to apply over the plate to just pull out the plate over the glycerin. Then the force that we are applying to pull out, that means we are equating that force to the frictional force. Means when we are applying a force over any particle or over in a plate, a frictional force also comes in the action. So when we equate that force to the frictional force and overcome that, we can pull out easily. So this is the application, and this is the numerical that what comes in the mains, and this is the concept of viscosity.